Algebra 2 Honors 3.5, and these are the notes for both day 1 and 2. And so here we go. We are going to be solving nonlinear systems, meaning systems of equations that have something other than just lines. And one system that we're looking at today is a line and a parabola. And you can see there's ways where you can have no solution, one solution, or two solutions. Those are the possibilities, depending on if the line intersects the parabola at all, or in 1 point or in 2 points. And with two parabolas, you have the same results. They might not touch at all, so there'd be no solution, or they might meet at 1 point and have one solution, or they could intersect and have two solutions. So we're going to look at this both algebraically and by graphing. So the first one is solve the system by graphing. And so you need to just kind of look and be flexible from that other unit in terms of how to graph this. And so for that first equation, it actually factors. So using the x-intercept method of graphing would be a good way to do this. And it factors into x minus 2 and x minus 6. And so the axis of symmetry on that is going to be p plus q divided by 2, or x is equal to 4. And then we can plug that back in. And you end up with 2 times a negative 2, and the y-coordinate is negative 4. So the vertex is 4, negative 4. And that is a parabola with an a coefficient out here of just 1. So it's going to have the normal opening. So if I go to the right 4 and down 4, and to the right 1 of that, up 1, to the left 1, up 1, to the right 2, up 4, to the left 2, up 4, and you should go to the right 3 here and go up 5, because, or up 9. So if you go to the right 3 from the vertex, 3 squared is 9, so up 4 and 1, 2, 3, 5, and know how those open up. Of course, we should know and expect it crosses at 2 and 6 because those are the x-intercepts. So graphing, make sure that it is rounded at the bottom, and make sure that you put arrows indicating it continues to go. And so then the line, if we graph y is equal to 4x minus 24, well, that y-intercept of negative 24 is way down there. My graph doesn't go that far without changing the scale. And so for the second graph, I want to just find out the x-intercept, which is when y is 0. And the x-intercept is at 6. Oh, so there's a point right there on this line at 6. So that's a point is 6 comma 0 on this. And then I can use the slope of 4 to generate more points. So a slope of 4 is going to be up 4 and to the right 1. And so I'm going to just regraph this parabola because I need it to not quite go through where this line's going to go. So if I go up from that x-intercept of 6, 0, up 4 and to the right 1, it actually goes right there. Or if I go down and to the left 1, it goes here. So we would say that that line, we call that line to be tangent to the parabola because it just comes and intersects that parabola in that 1 point at 6, 0. And so the solution is going to be 6, 0. So this is that's the ordered pair that they share. All right, and there's other ways. We could have used a negative b over 2a in the quadratic since it was in standard form. So there's more than one way to graph the parabola in example 1. All right, number 2, solve by substitution. So you need to watch the wording on that because you are going to need to use the process asked for. And so substitution means we solve one of them for a variable and substitute that result into the other equation. And so I would just take this second equation and solve it for y, and then substitute that value of y into the top equation. And so we have x squared plus 2x minus, now you have to have minus the quantity. That's a place where people will make errors because you have to negate the entire quantity. So what we're trying to find is the set of ordered pairs that satisfy both equations. So I'm going to set it equal to 0 and find the zeros by using the zero product principle. And so x squared plus 4x minus 12 factors. And so when x is -6, I'm expecting a solution. Or when x is 2. So that's telling me, oh, I must have, this is a line in a parabola, right? This is linear. This is quadratic. So they can have no solutions, one solution, or up to 2 solutions. In this one, this must mean that that line intersects the parabola in 2 points. So we have the x coordinates. We need to go and find the y values. So I'm going to plug the x values into this y equals 7 minus 2x. Notice the communication, how I'm working down the page. I have equal signs. I have full complete expressions. And 7 minus, or plus, that's a -6. There we go. So 7 plus 12 is 19. So one of the solutions is that ordered pair, -6, 19. But x equaling 2 will produce a second set of, or second ordered pair where they intersect. And we get 7 minus 4, which is 3. So we'll just put a comma, and our second ordered pair is 2, 3. So if I were to graph those, I expect those are the 2 points where they intersect. And so if I plug them back in, both points should make the top equation true and the bottom equation true. All right, example 3, here we have 2 parabolas, which could have no solution, one solution, or 2 solutions. And so solve by elimination. And so they are set up kind of nicely. Notice if I add them right now, the y values will disappear, which is what I need to have happen. I need to have them set up so that I get it just in terms of x or just in terms of y. And so it'd be trickier to get rid of the x squareds and the x's because you have to have something that gets rid of both of those. This is set up to eliminate the y just purely by adding. So draw the lines to indicate you're going to do addition and add those. Notice you must start by copying the original problem down. I need to know what the original set of problems were. That must happen. And when you're solving by graphing, I need you to use graph paper. So we eliminated the y by just adding those. I'm going to set it equal to 0. And everything, it's an equation. Everything has a factor of 2, so I'm going to divide through by 2 just to have smaller numbers to work with. And 0 divided by 2 is 0. I'm dividing both sides. And if I start trying to factor this, 2x and an x, and to get a positive one, but have a negative in the center, this does not work. That gives me a minus 3x. This isn't going to factor, and I can use the lesson on the discriminant and look at the value of b squared minus 4ac to know the possible solutions. And so b squared is 4 minus 4 times a times c. And that comes out to -4, which is less than 0. So there are no real solutions because it's imaginary. And graphically, when we're looking at these, we are just looking under the reals, or just in, so we're just looking for real solutions in this section. All right, so there are no real solutions. So moving on. Solving a nonlinear by substitution. So we had one above, and now we have another one, but it just has, this one actually isn't just a parabola. This one is a circle. Maybe you remember from geometry, the x squared plus y squared equals r squared is a circle centered at the origin with a radius of r. And so this is a circle with center 0, 0, and a radius equal to the square root of 20, which we can write 2 root 5. And so we have a circle. And so if I think about a circle and the second equation is linear, again, I could have where the line doesn't intersect the circle, or I could have it where the line just touches the circle in one point, or it could be that the line passes through and touches the circle in 2 points. So I have all those possibilities again. So in this case, it's ready for substitution. Y is already solved for x plus 2, so I can replace y with x plus 2. And the square of a binomial is a trinomial. Square it, multiply, and double it. So when I multiply this out, I get an x squared plus 4x plus 4. So 2x squared plus 4x minus 16 equals 0. Again, everything's divisible by 2, so make it easier on myself. I'm dividing both sides by 2. And then if I factor this, x plus 4, x minus 2, that means I'm looking at two solutions. So I have x when x is -4 or when x is 2. And I'm going to plug those into y equals x plus 2. So when x is -4, I get a -4 plus 2, or y is a -2. So that means my solution for that order pair, when x is -4, y is -2. And for the second one, if I plug in 2, I get 4. And so my second solution is when x is 2, y is 4. And so evidently this line intersects that circle in 2 points, and those are my solutions. All right, so on day 2, you'll have some repeat of the other ones, just reinforcing those. But then we have something a little different here. Solving equations by graphing. And so to solve an equation f of x equals g of x, you write a system of two equations, y equals f of x and y equals g of x. So right here in part A, that means I'm going to write y as the left side, and then y equals the right side. That's what that means. Rewrite them as a system of equations. And then graph them, but this is super important, it is just the x value of the points of intersections that is a solution. Because notice in the original problem, there is no y value originally. And so we're just looking for the x value that makes the left side equal to the right side. So that's where this is different. We're still going to think of them as two separate graphs, but it is only the x coordinate. And so on this one, using a graphing utility is okay. We can go through the negative b over 2a, but I'm going to go ahead and, I mean, you should have skills that you can find the axis of symmetry and plug it in and get the vertex and use the vertical stretch to do this. But I'm going to go ahead and put this into Desmos and solve by graphing. And so I'm going to take those two equations, go to Desmos, and clear that out, and clear the second one. By the way, if you don't have a second equation, I'll show you how we add that in. So I'm in desmos.com, and I'm going to put in that first equation. So we have 4x, and then hit the a squared button to get that squared, and then plus 7x and minus 3. So there is my first one. And then what we do is we hit the plus button, and I'm going to do an f of x expression. Now, they don't take the function notation. You have to just use y equals. So y equals, and then plug in the right-hand side, a minus x, hit the a squared to square that, and then minus 4x and plus 2. And so these happen to intersect in 2 points. And so I can actually in Desmos just hover over it or tap it, double tap it, and there I have that first point of intersection. And so the x coordinate of that point of intersection, a negative 2.587. If we go to 3 decimals, I think I had 2 decimals is what I put on my paper. And then this other point of intersection, be careful because you don't want the x-intercept of the function that's parabola is opening down. You need the point of intersection. Now, just a couple of things. The vertex of the second equation is negative 2,6, and the vertex of the top equation isn't as pretty, so a negative 0.9 and a little bit more than negative 6 down. So we'll just use that and sketch those. And so what I did is I kind of pre-saved these in Notability so that then we would come and copy that graph down. And so we had negative 2,6, and then the y-intercept is 2 on that one. This is the second equation that's opening down. So if I use symmetry, there's another point, and it looks about 4.5-ish. That's where that's going through, and then slightly over here. So sketching. And that did have a coefficient of negative 1. So if I go to the right one, we're down 1. If I go to the right 2, I'm down 4. Put the arrows to indicate that it's continuing to go. And then this first equation that opens up was that negative 0.8 something and down, or a little bit below 6. And its y-intercept was negative 3. And if you then just go to graph this, we know that it has an intersection right here, and you should put that on your graph. But we found it just using Desmos. And then we have also that negative 2.5. So we're just going to go ahead and sketch this. And so this ordered pair is the negative 2.587, oops, comma 5, oops, 5.656. So that is that ordered pair for that point of intersection. But the answers, the solutions, which you need to, you're not done until you have pulled those out and answered it. The solutions on this are just x equaling, if we go to 2 decimal places, 0.39, or x equals negative 2.59. In calculus, you do 3 decimals. I don't know, I just did 2. But the solutions are not the ordered pairs, they are just the x values, because there were no y values in the original. So we're using graphing, but you need to have an accurate sketch. And there you go. So there's that one. And I'm just going to move that down back here. Now let's look at this next one. Solve by graphing. And in this one, these are set up in a form where you know how to graph these. And so, of course, I guess we did before too. We could have used negative b over 2a. This top one, remember, take each side and let it be equal to y. So just be prepared, you know, something I might ask you to use Desmos on. Otherwise, I will expect you to use previous knowledge to be able to graph these. And so for that top equation, I know the vertex of this is 3, 4, and it has an a value of 1. So if I go to the right 3 and up 4, I've got that vertice. And then it's opening up normally. So to the right one, go up 1, left one, go up 1, go to the right 2, go up 4, up 4. And so here I have, and again, you need graph paper on these. So there's the y equals quantity x minus 3 squared plus 4. Now the next one, the intercepts are 0 and 6. So if I go ahead and get that axis of symmetry, the axis of symmetry is going to be x equals 3, which it was also for the other one. And if I plug that x value of 3 into the equation, I get a negative 4/9 times 3 times a negative 3, which is a negative 9, and it happens to come out to 4. So the vertex for that second equation is also 3, 4, but this parabola opens down. And so that a value is not exactly pretty, a negative 4/9. So that might be a little bit harder, but I do have the intercepts, 0 and 6. So that's, you know, that's okay. We can just, since the goal is just to find out where they intersect, so that first is negative 4/9. So it's just going to go to the right one and down 4/9 instead of down 1. And there we've got that. And the solution, now remember, these are just, there is no y value. So that vertex, which is the vertex for both, it is the x coordinate of the vertex because the original problem was in terms of x. So there's just one solution, and that solution is x equals 3. And that's it.